Hello guys, welcome to the channel. In this particular video, I will be explaining the problem CamelCase Pattern Matching. So let's see the problem statement. Here is the problem. It says that given a dictionary of words where each word follows camel case notation, print all words in lexicographical order in the dictionary that match with a given pattern consisting of uppercase character only. Okay, fine. So what exactly is a camel case notation? Let me explain. So even this is given at this point, you can see that camel case is the practice of writing compound words or phrases such that each word or abbreviation begins with a capital letter. Let me explain this thing. It's whenever we talk about compound words, so we are talking about a group of words. For example, let me write R equal. You can see that we have two words here. First is R and the second is equal. So this is a compound word, right? Now, what is camel case? Camel case says that whenever a new word starts, then you have to start that word with a capital letter. And in the camel case, there are again two types. The first one is lower camel case. Let me write camel case here. So again, we have two types: lower camel case and upper camel case. If you are a Java coder, then you must have seen both of these types. The first one is lower camel case. Whenever you write a function in Java, then you write function like this: r then equal, right? This is how you write a function. What's special about this function is you can see that a new word is starting with a capital letter, so it's following a camel case here. And since the starting letter is a small letter, then you can see that you can say that this is a lower camel case notation. And what about the upper camel case? Upper camel case is basically if I write something like this: r then equal. So this is something which is upper camel case notation. And where it is used, it is generally used when defining the name of a class in Java. So this is what the camel case notation is. Now let's talk about the problem. The problem is quite simple. It says that you are given a dictionary, and dictionary contains words with camel case notation, and you have to print those words which are following the given pattern, right? Now let me explain with this example. In this, we are given a dictionary, and this dictionary contains three words, right? And you can see that all these three words are following the camel case notation, and the pattern which is given to us is WTG. So any word that is matching with this pattern, we will write that word. For example, this welcome geek is basically following WG, this particular pattern, right? First we have welcome, then we will take W from the welcome, and then we will take G from the geek, right? What about this particular word? It follows W, T, G, F, G, right? So I'll write W, T, G, F, G. Okay, and what is here? Here I'm following G, F, G, right? Geeks for geeks. So I'll write G, F, G. And okay, there is no other word, so you can see that we have three words which are following these particular patterns, and the pattern which is given to us is WTG. So what I'll do is I will take this particular word. Why? Because you can see that WTG is something that can be found here. So now the task is quite simple. We have to return the word which is following this pattern. So I'll return welcome to Geeks for Geeks from here, right? Okay, so from the problem you can observe one thing, that what I'm actually doing is I'm matching the prefix here, right? So whenever it comes to prefix, then we can use something like try. We can use try. Okay, so the task is quite simple. The task is quite simple, that store all the words in a try, and then just okay, so you have to store the okay, so you have to store these patterns in the try. And once you have stored this pattern, then you can simply match the prefix with this pattern. This is how the try works, right? But I'm here not going to show you the approach for the try, because the reason is let me erase all these things. Okay, so let me change the eraser here, and now I'm not going to show you the try approach. The reason is the try approach is going to take the complexity of n cross length of the longest word, right? And if you have seen the code of try, then you will find that we have two methods which are going to make our code so long. So I don't think that this is an optimal approach to use the try here. But if you are someone who is learning the try data structure, then you can surely apply the try. But what I'll do is I'll show you the naive approach, and naive approach is going to work fine for this. Let me show you. I have taken the same example here, and for this example, what I'll do is I'll traverse all the words in the dictionary. So, and when traversing the word, I will what I'll do is I'll try to convert every word into its like pattern, right? So for this word, I have the pattern H. Again, for this word, I have the pattern H. And what about this word? For this word, I have the pattern HW, right? And for this word, I have the pattern HT. For this, I have HG, and for this I have H, T and then W. Okay, now for this I have H, T and C. And what about this one? For this I have H, T and L, right? So these are the patterns that I have, and I have to match these patterns with this particular given pattern, right? And you can see that there are four words, 1, 2, 3 and 4, which are matching with this pattern. Fine. And what I'll do is I'll simply return these words, but there is a particular ordering that I should follow. The ordering is, you can see that it is given in lexicographical order. I have to print all the words. So what I'll do is, first of all, I'll print high tech. After this, I will pattern. Okay, so I have three words now. And you can see that this word is lexicographically smallest word. Why? Because it is starting with letter C. So I will write high tech city. After this, I'm going to write this particular word, high tech lab. And after this, I'm simply going to return high tech word. Right, this is something that I need to return, and this is nothing but a list of string, right? This is a list of string. So this is how we can solve the problem. Now I'm going to show you the pseudocode. So pseudocode is quite simple. First of all, traverse all the words in the dictionary. So for each word in dictionary, for each word, what I'll do is I will traverse every character of the current word. Let's say I have the word high tech. So for this word, I'm going to traverse all the characters of this word. So I'll write for each character in word, and for each character, what I'll do is I'll do a simple task. I will check if the current character is uppercase, if ch is greater than equal to a, and ch, which is current character, is smaller than equal to z. This is how we check the uppercase character. And once we have found that this is uppercase character, so we have a string here. We are going to append to that string. So let's say I have a string st equals to empty string, then st is going to increment by the current character each time, right? This is how we will have h and t, right? This is how we will have the pattern for the current word. And once we have the pattern, what we'll do is we will simply check if pattern is equal to the current pattern, right? The given pattern. But there is small thing that we need to observe, that we are matching with prefix, right? And once we are matching with prefix, so what we will do is uh, in this particular loop we will check st if st dot equals pattern, given pattern. In that case, we can simply break, right? We can simply break. This is how we can check for the prefix of every word. Let's say I have ht, then instead of checking this w, I know that this st is matching with this st, right? So I'll break at this point, and I will have a flag, and I will make that flag true so that I can store this word. Let me tell you what I mean. So first of all, let me remove this, and I'm going to use these brackets at this place. Okay, now once this loop is completed, in that case, what I'll do is okay, so let me change the color now. Once this loop is completed, after this loop, I can check if whether I have to store this word, right? So I will have a flag also. So I will make flag equals to true, and initially the flag will be false. So I will write flag equal to false, right? This is what we can do. And once I know that the flag is true, this means that I have to store the current word. So I'll write if flag equals to true. In that case, answer dot append the current word, which is let me write word here. So this is how we can solve the problem. And what is answer? Answer is basically the final array, list of string that I need to return. So answer is basically the list, right? Now this is the code that we can write to solve this problem. Okay, so am I missing something? Let me check. At last, okay, so this is an extra bracket here. Let's remove this, and instead of using green, let me write this color here. Okay, so at last we just need to return the answer. We can simply return the answer. Now I hope the idea is clear to you. So once the idea is clear, let me show you the code now. So this is the code. On the left hand side I have the code in Java, and on the right hand side I have the code in C++, and then the code in Python. Okay, so now what is this sorting? Sorting basically comes from the fact that we have to return the characters in the words in lexicographically order, right? So this is why I'm sorting the dictionary first. And after this what I'm going to do is I'm simply going to do the same task that I have explained you. You can see that, okay, this extra line is here to handle that case where we have an empty array at the end, so we need to store -1 in that array, right? Okay, now you can see that same C++ code is written here. What about the Python code? In Python code, it just works without sorting the dictionary, like sorting the dictionary. So that's why I have not sorted the dictionary. Okay, so this is all about this video. I hope you guys like the solution. Now let me show you the time complexity also. What is the time complexity? The time complexity is basically going to be, first of all, I'm sorting the dictionary. So this is basically sorting the dictionary, right? After this, I'm doing one more task where actually this particular task. So for this particular task, I'm traversing each word in the dictionary. So this is O of n. And after this, what I'm going to do is I'm going to traverse each word. So this is O of the length of the longest string. And what about this? Like I'm checking here, right? But this is not going to create a very big impact, because the pattern is always going to be smaller than the this particular word, right? Each time, like I have a greater word, then the pattern will become smaller. Even we have the length of word, maximum length of word is 100. So in that case, I can have at most 100 characters, right? So this is what the time complexity is. It will be O of n cross s, right? Plus okay, so let me write in the uh, right order. So I'll write O of n log n. This is for sorting the dictionary, plus n cross s. This is what we are going to use. This is the time that we are going to use in order to solve the problem. And is there any time complexity? No, we are not going to store any word. So this is the video. This is the explanation of the problem, and you can also solve this problem using this the tried array structure again. The reason is, whenever it comes to prefix, then we know that we can solve this problem using the tried array structure, right? Okay, so this is all about this video. Thank you.